Hello, and welcome to our first lesson in Pre-Calc 2, where we are going to talk about angles and radian measures. So some of you are probably thinking, well, what exactly is a radian? So before we get into defining a radian, let's kind of review some of the very first things you learned about angles in general. So every angle is going to start what we call an initial side. And then we are going to, for pre-calc, we're going to rotate that initial side to a certain point. Then it's going to stop. And we are going to get a terminal side. So throughout this course, we'll hear us talk about initial side, terminal side. Now, I purposely drew the initial side perfectly horizontal like that because you're going to learn really quickly that we are going to place most of our angles on something we call a unit circle, which is embedded in a rectangular coordinate system. So essentially, you need to start thinking about that initial side as always lying on the positive x-axis. And as we move through this course, all of our angles are going to start there and rotate in a counterclockwise position around the coordinate system. So let's get back to the different parts of our angle. That corner piece is called a vertex. And then the angle itself falls between the initial side and the terminal side if you're counting in the counterclockwise direction. As long as our angle measurement is positive. Now, if we change that and move on to a negative angle measurement, well, there's our initial side. We would simply go in the clockwise direction. This angle would have a negative measurement between the initial side and our terminal side. So, counterclockwise, that's our positive angles, and clockwise, that is our negative angles. Now, you are very familiar with degrees, and you've worked pretty much throughout your whole education up to this point in degree measurements. So, if I go back to our angles, and I start with my initial side here, and I draw an angle that is only this big. Recall that we call these acute angles. And what makes an acute angle acute? Well, it's a small angle, but it's an angle that is particularly less than 90 degrees. So in other words, it is an angle that is greater than 0 degrees, but less than 90 degrees. And then, of course, our 90-degree angle, which we usually represent by that box, is a right angle. And we will work a lot with right angles in this particular course as well. And that is a 90-degree measurement. Angles that are greater than 90, but less than 180 degrees would be our obtuse angles. We won't really use the term obtuse much in this class, but we will certainly use acute angles and right angles. But these particular angles are definitely greater than 90 degrees, but they are also less than 180. So, what does an angle that is 180 degrees look like? Well, as you probably recall, it is a straight line. Here's our initial side, and here's our terminal side. It is at a 180-degree angle, and it is also called a straight angle. So, again, how does all of this, hopefully all of this is you remember from probably middle school mathematics, get us back to our initial question. What is a radian? Well, if you take a circle and I go ahead and draw my initial side from the center. There's the center of my circle. And there is my initial angle. If you're looking at that, you're thinking, oh, that's simply the radius of the circle, right? So let's call that R for radius. Now, if I draw my terminal side in such a way that the distance from this part to that terminal side is also R, so again, that too is a radius because it's all coming from the center. But, so if I draw my initial side and my terminal side such that if I were to travel along the circle from my initial side to my terminal side, the angle that that creates is called 1 radian. When we stick an angle inside the unit circle, by the way, it becomes a central angle. A central angle is simply an angle that is centered at the center and has its sides as the radius. Now again, if that center angle is the same, so we'll call this position 1, position 2. If the distance between position 1 and position 2 is the length of the radius, then that angle is considered to be 1 radian. So a radian is a measurement is the measure of a central angle that intercepts an arc equal in length to the radius of the circle. Equal in length to the radius of the circle. All right, and an arc is simply a portion of the outside of our circle. Okay? Okay, so now if we generalize that and we come down and we draw ourselves a circle, and let's suppose we have an initial angle and we have a terminal. We have an initial side and a terminal side. And this will be our angle, our central angle, theta. The arc length, which goes from here to here, oops, let's call that S, because clearly it is larger than our radius in this case. We can say then that theta would simply be equal to the length of the arc divided by the radius in radians. So in other words, if the arc length was double the radius, well, you would have to divide by the radius, and you would get 2. So it's a relationship between our angle and the arc length. And that's what radians gives us. It gives us that relationship. So, for example, let's suppose we had an arc length of 15 inches. And we had a radius of 6 inches. Well, given the arc length and the radius, we could determine that the angle is simply S over R, which would be 15 inches over 6 inches, or 2.5. Now notice there's no measurement for radian. The inches cancel out. We do not have a symbol to represent radians. So when working in degrees, we'd always put a little degree symbol. If you don't see a degree symbol and it's a measurement for an angle, you would have to assume then it's radians. And we can always write the word radian after it. But for the most part, it is such a commonly used measurement in mathematics that any time an angle is measured in radians, it doesn't have the degree symbol. So for example, that represents 4 degrees, but that represents 4 radians. So you kind of have to get used to, when you are working in degrees, make sure you use a degree symbol. But when you are working in radians, there is no symbol you need to put after the number. It is understood that that is a radian measurement. Now, so you have to ask, well, what is this relationship now between degrees and radians? To think about that, we're going to look at an entire circle. So draw yourself a full circle. And I want to look at S as the entire circle. In other words, I'm going to draw my initial angle, but this is also going to represent the terminal side of the angle as well. So our theta is going to start and loop all the way around. So in other words, the arc is simply the entire circle itself. Well, we know the measurement of that arc because you learned in your high school geometry classes and everywhere else that the distance around a circle is called a circumference. And you know that the circumference is 2 pi r. So, for any circle, that circumference is the same, 2 pi r. So if we start to figure out our angle measure, we would start by saying in radians, well, we know the relationship is S over R for radians. So we have 2 pi r. Whatever r happens to be, doesn't matter. It could be a really small circle, it could be a humongous circle. We're just going to divide by r. Well, you can cancel out the r's, and we're left with just 2 pi. Okay, well, this is in radians. Okay, in degrees, let's just go with our prior knowledge. In degrees, we know that 1 complete rotation around a circle is 360 degrees. So, in radians, 1 complete rotation around a circle comes out to 2 pi. In degrees, 1 complete rotation is 360. So therefore, 360 degrees is the equivalent of 2 pi radians. We can simplify that a little bit because the 2 and the 360 can be reduced. We can divide both sides by 2 and simply state that 180 degrees equals pi radians. This is what you can do to convert. Now, while in the beginning of this class, we learned how to convert angles between degrees and radians, as you progress, you are going to get very comfortable working with radians, and you will no longer need to do these conversions. But I can understand in the beginning, radians is a little bit of a foreign measurement to you, and putting it in degrees, which is something you're familiar with, makes things a little bit easier. But don't worry, you'll get really good at working in radians by the end of your pre-calc class. Because once you get to calculus, unless you're doing an application problem, if you're doing more of a theoretical problem, you're going to be working in radians. So, because of this, what we can do is set up ratios. Right? If 180 degrees equals pi radians, well, that means that 180 degrees divided by pi is the same as pi divided by 180. And essentially, the relationship will help us convert. Now, which of those you use depends on the conversion you're doing. So let's start with converting degrees to radians. Start with what you are given. Let's suppose we are given 30 degrees. If you remember doing conversions back in your high school science classes, when you do conversions, you always create fractions. So we're going to put that 30 degrees over 1. And we're going to multiply it by one of these relationships. Now, because I want to cancel out the degrees, I'm going to use the relationship that has the degrees in the denominator. So I'm going to multiply that by pi over 180 degrees. Because then my degrees can cancel. And I have 30 pi over 180, reduce it, and that comes out to pi over 6. So 30 degrees is the equivalent of pi over 6 radians. This is one of the most used conversions, and it's one you're going to get familiar with very, very quickly. So we're going to do a couple more that you're going to get familiar with pretty quickly. Let's do 90 degrees. Well, 90 degrees over 1 times pi over 180. Degrees cancel. You have 90 pi over 180, which of course is going to come out to pi over 2. And as you can imagine, this is going to be another very familiar and one that you will use a lot. So from now on, when you're thinking about pi over 2 radians, you are thinking about a right angle. And another common one is 45 degrees. And 60 degrees. So you can hit pause real quick and go ahead and calculate those and then unpause it and you'll see the answers. And hopefully you got pi over 4 and pi over 3. Now, as I stated, I purposely gave you these 4 degrees because they are some of the most commonly used angles. So you'll almost start to memorize them and you'll be familiar with them because you'll think 30 pi over 6, 60 pi over 3. Notice how 3 and 6 rotate. They're not the same. 30 is pi over 6, 60 is pi over 3, 45 pi over 4, pretty easy to remember, 90 pi over 2, and so on. So understanding these will kind of really help you so that you can start working with radians and know, well, any radian that's less than pi over 2 is an acute angle. Radians that are greater than pi over 2 are obtuse angles, and so on. So let's go in the other direction. Maybe you're working in a radian measurement and you just feel more comfortable knowing what would that be in degrees. So let's do 5 pi over 3. So think about it. To convert to degrees to radians, notice when I wrote the fraction, I put the degrees in the 180 degrees in the denominator because I want the degrees to cancel. But when I do 5 pi over 3, I want the pi to cancel. So I'm going to use the ratio 180 degrees over pi, because I want the degrees to be left in the problem. So my pi's cancel, and I have 5 times 180 degrees over 3. I left it like this so I can quickly cancel out 3 into 180. Right, 3 goes into 180, 60 degrees. So it's 5 times 60 degrees. And 5 times 60 degrees is going to give me 300 degrees. So 5 pi over 3, well, that kind of makes sense, doesn't it? Because if it takes 2 pi to get to 360 degrees, 5 pi over 3 is just short of 2 pi, because 2 pi would be 6 pi over 3. So it would be really close to 360 degrees. Now, most of the time, your radians are going to be given with the pi symbol in them, but not always. So you need to be careful. So if you were asked to convert 1 radian, I wonder how big a radian is. You would just have the number 1. You still use degrees in the numerator, pi in the denominator. So technically, this is pi radians, so they would go away. And you have 180 degrees divided by pi. Well, yeah, gets us right back to kind of where we were. But we can estimate that, just so you can have an idea about how big a radian actually is. So we can divide by approximately 3. So this is an approximation. And approximation would be about 57.3, not 6, degrees. So 1 radian is approximately 57.3 degrees. Now, a quick little note on approximations. It is rare in this course that we will work things out to approximations. Very often you will give what we call exact answers, and exact answers would keep that particular measurement as 180 degrees over pi. But don't worry, on exams you will be explicitly told if you are to do an approximation and exactly how many decimal places to approximate it to. If not, you will also be told you must give answers in exact form. Exact form means pi remains in the answer, you can't approximate it, and any radicals remain in the answer. So let's move on to drawing angles in standard position. As I said, we are going to look at angles as they rotate around in a coordinate system. To do that, you need to get really familiar with drawing them in standard position. Now, doing this in degrees, which is where we'll start, is a little bit easier for you to think about. So let's start in degrees, and then we'll move to radians. So let's suppose I want to draw in standard position, 45 degree. Many of the problems we do in this class, you will need to draw these little rectangular coordinate systems. So every angle starts at the initial side, which is the positive x-axis. And you will start here. You will rotate exactly 45 degrees. And there's my angle. Now, when you draw an angle in standard position for an exam or anything else on your worksheets, before you upload anything, I will need the picture. I will need the arrow. So why? Well, what if I did 405 degrees in standard position? Well, Again, there's our initial side. To do 405 degrees, that means you first have to make a full 360 degrees rotation. Oh, so now we need to figure out what's 405 minus 360, and then go an additional 45 degrees. So if you did not do the movement of the rotation and show that on your paper, they would look exactly the same angle. They're not the same angle. Clearly, 45 degrees and 405 degrees are not the same angle. But as you'll learn very quickly, they are what we call coterminal angles because they have a terminal side in the same location. And there's a lot of different coterminal angles that we can work with. So, for example, can you think of a negative coterminal angle with 45 degrees? Did you get it? 315. So how did I do that? Negative 315, sorry. Well, for a negative angle, as I mentioned earlier, we would start and we would move in a clockwise position. So that's 180. That's 180 degrees to get to here. 270. And then we would need an additional 5 degrees. The other way to think about it is simply take that negative angle and add 360 to it. If you add 360 to it, you will see you get a 45 degree angle. So negative 315 and 405 are both coterminal with that 45 degree angle. But when you have to draw the angle in standard position, you can tell by the pictures, they all look very different. So it's very important on exams that you draw these angles very carefully. And it's also important that you know where your measurements are around your coordinate system. As I said, in degrees, it's easy. It starts at 0 degrees, goes to 90 degrees, goes to 180 degrees, and then to 70 degrees and back to 360. That's going standard position. Of course, 270 is also the same as negative 90. 180 is the same as negative 180, and 90 is the same as negative 270. So, in degrees. Becoming familiar with everything in degrees will really help you because you are going to have to move to working in radians, not degrees. And yes, we can rotate and do things like, we'll do just a crazy one before we move on. I'll just say 1065 degrees. Well, to do 1065 degrees, you're going to have to take away a whole bunch of 360s. So you start by plugging in 165 in your calculator. Subtract 360. Well, now we're at 705 degrees. Oops, I forgot to put the minus 360. We're going to take away another 360. Oh, now we're at 345. Oh, okay. How many times did I rotate around? Well, I rotated twice before I got to 345. So that means 1, 2, and 345 is going to bring us all the way pretty close to that, but not quite. Okay? So there is our 1065 degree angle. Okay. That's all great, but what you really need to do is start to practice being able to do coterminal angles in radians without changing them to degrees. And that's the tricky part. The best way to do this is practice. Now that you understand the idea, let's first take a look at our unit circle, or our coordinate system. We'll get to the unit circle in another chapter. And And let's think about it in radians. Because again, your goal through this first chapter is to stop thinking in degrees and to start thinking in radians. So if I were to think about that in radians, well, 0 degrees and 0 radians are the same. Notice I don't have the degree symbol. That tells me I'm in radians. Now we already did, so I'm going to scroll up for a minute on my screen. We already said, oh wait, 90 degrees, which we know is that right angle mark, or the positive y-axis, is simply pi over 2. And then we saw that 180 is pi. And if you did 270, you would see that is 3 pi over 2. And then, of course, 2 pi gets back to our 0 radians. That's going to be really helpful to you as you start to think about where angles go in radians. Now, the hardest part is actually working with the fractions. In other words, if I were to give you an angle, so suppose I gave you pi over 12. Well, where does that angle fall? Obviously, it's greater than 0. And is it smaller than pi over 2? Well, yes. In fact, any angle that simply has a pi in the numerator, but a number larger than 2 in the denominator, like pi over 3, pi over 4, pi over 5, pi over 6, pi over 10, any of them are going to be in that first quadrant because they are going to be less than 90 degrees. And if you're not sure, you can convert it and check for yourself. Pi over 12 is a rather small angle. So pi over 12 is simply going to be in that first quadrant right there. So there's the picture of it. Now, how about 3 pi over 4? Well, so now you got to check yourself. 3 pi over 4. And you can kind of almost forget about the pi part for a second. Think of that 90 degrees as a half, right? So you can kind of think like, let's say, yeah, this is simply a half, that's a whole, and that's 3 halves. Well, where does 3/4 fall? Well, 3/4 is greater than a half, but less than a whole. So yeah, 3/4 is going to be here. Now, one other thing you may want to start doing is thinking of these as your conversions as well. Anything over 4 is going to kind of be very similar to a 45-degree angle, because if you remember, 45-degree angle is pi over 4. So this is 3 pi over 4s. Pi over 4, 2 of them gets you to 90, and then 1 additional one. So you could have, oh, there's pi over 4, there's pi over 4, there's another pi over 4. That's 3 pi's over 4. So how you want to start thinking about these angles is really up to you. And just do what you need to be able to draw angles in the right quadrant. So we'll do one more. And let's do negative. Let's see, negative 7 pi over 4. A little bit harder than dealing with negatives in degrees. So what I would do, well, there's different ways to actually work around these negative angles. You can do them any way you want. You can just think of how many rotations you have. So one of the things you want to kind of get used to is, where does it fall in relation to 2 pi? Well, anything over 4, 2 pi would be the equivalent of 8 pi over 4. Does that make sense? And that's how you want to start thinking of your angles. So in other words, if I'm working with an angle that's over 3, 2 pi is equivalent to 6 pi over 3. So this is an angle over 4. So I want to think about 8 pi over 4. Well, 7 is just shy, in fact, pi over 4, 45 degrees, shy of a full 365 degrees rotation, 360-degree rotation. but it's negative. So it makes sense that I'm going to go negative, and I'm going to almost make the whole thing, but I'm going to stop short right there. The other thing you can do is take your angle and simply add 2 pi. But when I add 2 pi to something over 4, what I'm adding is 8 pi over 4. And you want to be able to work with these angles. So that gives me pi over 4. In other words, negative 7 pi over 4, remember, they are not the same angle, but negative 7 pi over 4 is coterminal with pi over 4. So that means it ends in the same location. They share a terminal side. The arrow tells you the rotation to get there. So there's our for 7 pi over 4. Now the other thing you're going to be asked to do to help you practice is just find coterminal angles. So if you're given an angle, you need to be able to find angles that are coterminal with it. So let's think about this. For example, I don't know, suppose I had the angle 420 degrees. How many angles are coterminal with 420 degree angle? Well, where is a 420 degree angle? It's positive, so we're going to go counterclockwise. It's definitely greater than 360. Oh, by how much? We got to do 420 minus 360. It's an additional 60 degrees, so we're going to go an additional 60 degrees, and it's going to be up here. So there's my 420 degree angle. Well, there you go. Right there, you just found an angle that is coterminal with it. So 60 degrees is coterminal with 420 degrees. How about a negative coterminal angle? Wouldn't negative 300 also be coterminal with that 60 degree angle? Because think about it, if I went this way, right? 360, it would be just 60 degrees shy of the full rotation. That would also be coterminal. So to get, again, in degrees a little bit easier to work with because it's something you're very familiar with. But if you're working in radians, it gets a little bit harder. What if I took 17 pi over 6? And I want you to find coterminal angles. Now, as we were saying before, and I didn't quite finish that thought, how many coterminal angles does every angle have? Well, obviously, we can go off into infinity in both directions. So there's infinitely many negative angles and infinitely many positive angles. On an exam, I will likely ask for 2, 1 positive and 1 negative, just so you can do a little bit of work. So let's think about that. How would I do that? Well, to get a coterminal angle, as we saw with the degrees, we could just add, or actually subtract, 360 degrees. But in this case, I could add or subtract 2 pi. So, to get a coterminal angle, I want to add and subtract 2 pi. Because 2 pi, every time we do that, we're going to get a coterminal angle. So let's subtract 2 pi first, because it is positive and it's going to be mighty large. But subtracting 2 pi with something over 6, I'm going to make an equivalent fraction, so I'm going to use 12 pi over 6. So 12 pi, 17 pi minus 12 pi is going to give me 5 pi over 6. Awesome. There's a great example of a positive angle. If I need a negative, I would have to subtract again in this case. Whoops. But I don't want to start with 17 pi over 6. I can start with my 5 pi over 6 because that's already coterminal. I can subtract 12 pi over 6. And that's going to give me negative 7. There. I have an example of a positive. In that case, because the angle was so large, we were able to find a positive and negative by subtracting 2 pi and then subtracting 2 pi again. Sometimes, depending on the angle, you will need to add 2 pi and also subtract 2 pi. So if I simply gave you let's say 2 pi over 3, find two coterminal angles. Well, I can take 2 pi over 3 and add 2 pi. So say to yourself, what's the equivalent fraction of 2 pi if I want something over 3? That would be 6 pi over 3. 8 pi over 3. There's 1. And then I can take 2 pi over 3 if I ask for a positive and a negative, subtract 6 pi over 3, and get negative 4 pi over 3. And you can sketch those angles out on your own and get how they are coterminal. So that's all we're going to do in this first section, where we dealt strictly with angles and radian measures. It is a really important section because, again, as you progress, you will need to start thinking in radians, and you can't constantly change to degrees and then try to change back. You need to actually start working. So when I say pi over 3, in your head you're thinking, oh, it's just a 60-degree angle. I know where that is on the, if I were to draw it out and put it in standard position. So that ends our first lesson.